Hello everyone. We will now work on question number 8 in project 2, which is about selecting the correct graph for a given trigonometric function. The function that we see here is a variation of the basic sine function, and they've given below 4 different graphs. We have to choose the correct graph that fits the given function. Now, the first thing to do in such cases is write the general form of the variation of a function. So that's what I'm going to do first. You may have to memorize that because it will not be given to you. It's y equals a times and then the function sine in this case. It could be cos or tan depending on what the equation has given to you. But for us, it's the sine function. So a times sine, and then within brackets, bx minus c plus d. Sometimes the letter k is also used for d, but for this example, let's use the letter d. All right. Now, once we have the form written out, we will take our given function and align it exactly as the general form that we wrote out. All right, because these letters A, B, C, and D, they will represent different variations of the graph. So if we can align the given function, we will be able to identify the values of A, B, C, and D, and then we can determine the different variations of the graph. So we have y equals, I'm going to write 3 just below A, and then we have the sine, and then sine of x, correct? So we don't see a visible coefficient to x, so I'm going to write it as 1 times x minus, we have to show the minus sign because the general form has a minus in it. And then here it's plus pi over 2, correct? So eventually we should get a plus pi over 2. But we've pulled out a minus from the plus. What are we left with? Minus pi over 2. And there's no plus outside the bracket, so I'm going to write plus 0. All right? So what do we have here? We have 3 representing A. So A and 3 aligned, correct? So the value of A is 3. The value of B is 1. The value of C is negative pi over 2. It is not positive pi over 2. C is negative pi over 2 because that's what we got after extracting the minus from the plus. All right, so whatever is left after you extract the minus is the value of C. And D has a value of 0. Now, what do A, B, C, and D represent? A represents the amplitude of the graph. In other words, it tells us how much the graph will stretch up or be pulled down. All right, so A represents amplitude. Let me write that. A is for amplitude, and the amplitude is determined by A. It's the absolute value of A, really. So if A has a value of 3, then the amplitude of the graph is 3. All right. So by saying amplitude equals 3, we actually mean that it's going to go up to positive 3 and it will be stretched down to negative 3. Next, we have B. Now, the B helps us determine the period of the function. Now, we know that the period of the sine function is 2 pi, but that is for the basic sine function. This is a variation of the sine function, so it may not have a period of 2 pi. So let's see how to determine that. The formula to find the period in the variation function is take the period of the the basic sine function, which is 2 pi, and then divide it by whatever B is. So what value does B have here? It has a value of 1, correct? So we write 1 for B. Let me write the formula first. So 2 pi divided by B is equal to 2 pi divided by 1, which is equal to 2 pi. That means there's no change in the period from that of the basic sine function. However, let's say B had a value of 2, then it would be 2 pi divided by 2, and the period would be pi units. All right? But for this particular question, the period will be equal to 2 pi. The next is the phase shift. What does the phase shift tell us? The phase shift tells whether the graph is going to shift horizontally either to the right or to the left. That's what phase shift means, the horizontal shifting of the graph. There's a formula to determine the phase shift, and that's C divided by B. What is the value of C here? It's negative pi over 2, correct? Negative pi over 2. What is the value of B? B has a value of 1. Therefore, the phase shift of the graph is negative. Let's write it down below. It's negative pi over 2. Now, what does this negative pi over 2 tell us? It tells us that the graph is going to shift horizontally to the left pi over 2 units. So what the phase shift essentially tells us is the horizontal shifting of the graph will be pi over 2 units to the left. That's what the phase shift is about. What does D tell us? D is about the vertical shifting of the graph. The whole graph might move up or it might move down. The entire graph. It's not about stretching or pulling down the graph. It's about moving the entire graph up or down. That's what D represents. What is the value of D? D has a value of 0. That tells us there's no vertical shifting of the graph. So let's write that. So vertical shifting is determined by D. If D is a positive value, then the graph moves up. If D is a negative value, the graph would slide down. However, in our case, D equal to 0, that tells us no vertical shift. There's no vertical shifting to the graph. So now let's take all this information and look at the different choice of graphs that we have here. The first thing is, let's look at the amplitude. Amplitude means that the graph is going to be stretched up to positive 3 along the y-axis and negative 3 along the negative y-axis. Let's look at the first graph. How far up does it go? It goes only to positive 1 and negative 1. Based on the function given to us, where a is 3, we would expect this graph to go all the way up to positive 3 and then below to negative 3. That is not the case. Right away, you don't even have to check the other parameters here. You can eliminate A. A is not the correct graph because the amplitude of this graph is just positive 1 and negative 1. Let's look at B. It's the same case here. It looks different. It's a narrow graph. A had a wider graph. For B, however, look at the amplitude. Again, it extends up to positive 1 and negative 1 along the y-axis. Therefore, it is not the right choice. Let's cross this out as well. All right, based on the amplitude of the graph, it should have gone all the way up to positive 3 and all the way down to negative 3. So A and B are eliminated easily. Let's look at C and D. In graph C, it goes up all the way to 3 and all the way down to negative 3 as well, correct? So at least it meets the amplitude requirement for this graph. So yes, this is a possible choice. Let's look at D as well. D also extends up to positive 3 and falls all the way to negative 3. Therefore, D could be a possible choice. So now that both of them meet the requirements of the amplitude, let's look at the rest of the information. The period. Is the period of C 2 pi? Let's see. The graph extends from negative pi here, from negative pi to positive pi. The length of the distance between negative pi and positive pi is indeed 2 pi, right? Negative pi to 0 is 1 pi and 0 to pi is another pi. Therefore, the period is 2 pi. It meets that requirement as well. What about D? D also extends from negative pi to positive pi. Therefore, it meets the requirements of the period as well. Both of them do. So let's go on to the next parameter, which is the phase shift. Now, the phase shift of the graph is negative pi over 2. That means all the points would shift pi over 2 units to the left, correct? Now, if we were to draw the sine function on this very scale, assuming that we use 3 for the amplitude, the sine function would look like this dashed line here. It would be 0 at 0 radians. At pi over 2, it would go up to 3, assuming that the amplitude is 3. And then at pi, it would go to 0. And then at 3 pi over 2, it would go to -3 and then go up to 0 at 2 pi. Correct? That's the basic sine. Well, not the basic sine function. You could say that's the graph of 3 times sine of x, so to speak. All right? What does the phase shift do to this sine function graph? It shifts everything to the left, correct? Therefore, this point here, which was at 0, will move pi over 2 units to the left, correct? It will now be located here. So what was at 0 in blue will move pi over 2 units to the left. What was at pi over 2, this point here, moves pi over 2 units to its left. So that means this point will move over here, correct? At 0. Let's look at the y value at pi. This point here will also shift pi over 2 units to its left. So that means this point will go here, correct? And then this point goes here, right? This point here also moves pi over 2 units to the left. And so does the point at 2 pi. It moves to the left as well. All right. What was at 0 now moves here. So now we see all these points, these red points, after moving these blue points pi over 2 units to the left, the red dots are all on the graph given to us in picture C. So that tells us that C is the correct choice. Right? It matches with all the different features of the graph. It matches the amplitude, it matches the period, it matches the phase shift, which is the horizontal shifting, and there's no vertical shifting involved. We already determined that. So why didn't we choose D? Although we have selected graph C, let's look at D. What is wrong with that? Why we didn't choose that one? As you can tell from the shape of the graph, it looks like it's been reflected. It's a reflection of the graph that we have in picture C. All right? And that is the reason we didn't choose it. It matches everything else. The amplitude matches, the phase shift matches, the period matches, but it is not the right choice because all the y values are negative. They are the reflection of the graph of the given function. In other words, if the function were given to us as -3 times sine of x plus pi over 2, if there was a negative sign, there's a reflection involved. In that case, D would be the correct choice. However, there's no negative in our function, correct? It was 3 times sine of x plus pi over 2. That's why there's no reflection involved. That's why C is the correct choice for us. All right? So that is how you can use your knowledge of graphing all the different features of the variations of a function and then decide which is the right graph for it. All right? We will now work on question number 9 in project 2. This question is pretty similar to what we worked in project 8. However, this time we will be using the cosine function instead of the sine function. We'll follow the same steps. First, write out the general form of the variation of a function. And that would be y equals a times, since we have cos here, I'm going to write cos and then within brackets bx minus, within the brackets there's a minus in the general form, so minus c plus d. In the next step, I will take our equation and align it and rewrite it to match the general form. That way it will be easy for us to identify the values of a, b, c, and d. So let's do that. Y equals 4 times cos of, now there's no coefficient of x visible. When that happens, the coefficient is a 1. So I will express the coefficient of x as 1 times x minus pi over 2. Now there's nothing after the brackets in the equation, so we will just write it as plus 0. Now let's identify the values of a, b, c, and d. A has a value of 4, B has a value of 1, C has a value of positive pi over 2, whatever comes after the minus sign, correct? Therefore, C will have a value of positive pi over 2 and D has a value of 0. Now let's put together what each of these values mean with respect to graphing the function. A stands for amplitude. The amplitude of the function will be the absolute value of 4, correct? So let's write here amplitude is determined by the value of A. It's the absolute value of A, which is the absolute value of 4, which is equal to 4. What does the amplitude mean? It tells us how far up and how far below the peak or the entire graph will be stretched. That's what A implies. It gives us information about the vertical stretch, not shift, stretch of the graph. All right? So we got that, and then we have the period, right? The period is determined by B. To determine the period, you take the normal period, the regular period of the cosine function, which is 2 pi. Let's write that. 2 pi divided by whatever B is. 2 pi over B. B has a value of 1. Therefore, the period is unchanged. It is 2 pi for this function. Next is the phase shift of the graph. Phase shift is determined by the formula C divided by B. That's the formula to determine the phase shift. C has a value of pi over 2 and B has a value of 1. Therefore, the phase shift is pi over 2. Now, pi over 2 is a positive value. That tells us the horizontal shifting. That's what phase shift implies, right? Phase shift tells us how far to the left or how far to the right the graph will shift horizontally. It talks about the horizontal shift. Therefore, based on the value of C over B, which is positive pi over 2, the horizontal shifting will be pi over 2 units to the right is the phase shift. What about the vertical shift? Vertical shift is determined by the value of D. We have 0 for the value of D. All right, D equal to 0. Therefore, no vertical shift. It doesn't apply to this particular function and therefore its graph. Now let's look at the different choices given to us. We have been given 4 graphs here. Let's look at the first one, A. The first criteria is the amplitude. Amplitude is 4, which tells us that the cosine graph, instead of going up to as far as positive 1 and negative 1 below, it should go up to 4 units up and 4 units down. Correct? Let's look at the graph of A. It goes up to only 1 unit and goes down 1 unit. Correct? Therefore, right away we know A is not the right choice. Let's cross this out. Let's look at B. For B, the amplitude, does that go up to 4 and down to negative 4? Yes, it does, right? This is 1, 2, 3, and 4. We see that the graph has been stretched up to positive 4 over the x-axis, and it has been stretched down to negative 4 below the x-axis. So that is satisfied. This is satisfied by B. Next is the period shift. Does the graph extend 2 pi units? Let's look at the interval within which the graph completes one cycle. It extends between negative pi and positive pi. That distance is 2 pi, correct? Therefore, that condition has also been met. The period of the graph in B is 2 pi. Next is phase shift. Pi over 2 units to the right is the horizontal shift of the graph. Now I'm going to draw the cosine graph here. Now the cosine graph with an amplitude of 4 and with no phase shift would extend like this. This dashed line, it would start from 4 at x equal to 0, and then at pi over 2 it would be at 0, and then at pi it would be at negative 4. On the negative side it would go down like this. It would start from 4, then to negative pi over 2. At negative pi over 2 it would come to 0, and then it would continue down like this. At negative pi, it would be negative 4, and so on, correct? This is how the graph would look for this function, considering there's no phase shift. When we introduce the phase shift of pi over 2, that means all the points of this green graph should shift pi over 2 units to the right. So let's mark some of the key points and see whether they have shifted pi over 2 units to the right correctly in graph B. So here we have the point at 4 when x equals 0, y equals 4. If we shifted pi over 2 units to the right, then it should be right here, correct? Pi over 2 units shifted to the right. What about the point here? The point which was here in this dashed line should now move pi over 2 units to its right. So what was at pi over 2 would move to pi, and that's where it is. And then what else do we have? The point over here on the negative side, the point which is right here at 0 should also slide pi over 2 units to its right. So that means it would be here, right? And this point below, which was at negative pi, it was negative 4, that should also slide pi over 2 units to its right. Negative 4 would now be located at negative pi over 2. And now we see that all these red dots are on the graph that was given to us in B, correct? Therefore, B is the correct choice. So I'm going to circle B, but let's look at some of the other graphs. D can be eliminated right away for the same reasons that we rejected A, because the amplitude of this only extends up to positive 1 and negative 1 on the other side, correct? It does not reflect the correct vertical stretch that the amplitude of 4 should have. So we can eliminate that. What about C? If you look at C over here, C is pretty similar to B. It has a vertical stretch of 4 units. It also has a period of 2 pi. It extends between negative pi and positive pi. However, this shifting is pi over 2 units to the left, correct? So if I draw my cosine graph like I did in green for B, this is how the cosine graph would look like without factoring in the phase shift, correct? And we see all the points here of the green graph has shifted pi over 2 units to the left, correct? This point at pi over 2 in green has shifted pi over 2 units to its left. That's not what the phase shift of this particular function is. It was pi over 2 units to the right. And that is the reason we rejected C as well. It matches the amplitude, it matches the period. However, it does not match the phase shift of the graph. It does not match the phase shift that the graph should have. All right. Therefore, B is the correct answer for this question. Hello, everyone. We will now work on question number 10 of project 3, which is also on graphing trigonometric functions. The function given to us is y equals negative 3 times cos of, within brackets, 3x minus pi over 2 plus 2 outside the brackets. Now, this is a complete function in the sense that it includes all possible variations that a graph could have. The first step will be to write out the general form of the variation of a function, and then we will align the given equation with the general form. That will make it easy for us to identify the values of A, B, C, and D, which will tell us how the graph is going to look like. So let's start with that process. We have y equal to, we start with negative 3, and then cos of 3x minus pi over 2 plus 2. Now we can align A, B, C, and D with their respective values, right? So A will have a value of -3. This negative sign has a special function that we haven't seen in the questions before. It tells us that the graph will eventually be reflected across the x-axis. But for now, let's just work with the values of A, B, C, and D, and then at the very end we will factor in the negative sign and reflect the graph across the x-axis. A has a value of -3, B has a value of +3, C has a value of pi over 2, and that's positive pi over 2. When you align your equation with the general form, make sure that the signs also exactly match as given in the form. All right. And D has a value of +2 as well after you extract out the positive sign. So let's start by working on what A does to the graph. A represents the amplitude of the graph, correct? So amplitude is determined by the absolute value of A. So it's going to be, in this case, absolute value of -3. Therefore, the amplitude of the function will be 3. What does that mean? It means that the graph will be stretched 3 units up above the x-axis and 3 units below the x-axis. That's what the amplitude does to a graph. It's about the vertical stretching or shrinking of a graph above and below the x-axis. Next is the period of the graph. The period of the function is determined by the formula. The period of the basic function, which in this case would be the period of the basic cosine function, therefore 2 pi divided by b. B has a value of 3, therefore 2 pi divided by 3 is the period of this function. What does the period determine? It tells us that the graph will complete one cycle within an interval of 2 pi over 3. That's what the period of a graph is about. It's the interval within which the graph completes one full cycle, right? The next variation is the phase shift. The phase shift refers to the horizontal shifting of a graph. The graph would shift either to the left or to the right horizontally from its normal position. That's what the phase shift tells us. It is determined by a formula as well, and that is C divided by B. In our case, C has a value of pi over 2, so it will be pi over 2. B has a value of 3, therefore pi over 2 divided by 3 gives us pi over 6. And that's the phase shift. The phase shift has a positive value. If the value of the phase shift is positive, then the graph slides horizontally to the right. If the phase shift is a negative value, it would slide horizontally to the left. In our case, we have a positive value, so the horizontal shift will be pi over 6 units to the right. Pi over 6 units to the right. And then we have the vertical shift. Now the vertical shift was something we didn't see before. Here D has a value of 2. D represents the vertical shift of the graph, which means the entire graph will either slide up or it can slide down depending on the sign that D has. If D is a positive value, then the entire graph is going to slide up. If D is a negative value, the graph is going to slide down the x-axis. So let's write that here. The vertical shift is determined by the value of D. All right. So D has a value of 2. Therefore, the graph moves up vertically by 2 units. So now that we have determined all 4 transformations, the amplitude, the period, the phase shift, as well as the vertical shift, we will have to go ahead and select the correct graph that matches the function. Now, since this involves a lot of variations, in fact, all of the variations, including a reflection that is determined by the negative sign before the function, it's easier to first draw a graph ourselves and then match it to one of the choices. All right. So let's just draw the graph step by step. All right. Now, this has a period of 2 pi over 3. That means the cosine graph is going to complete within a period of 2 pi over 3 units. Again, I'm going to move step by step. I'm going to draw the graph of 3 times cos of 3x to begin with. And then we will add the minus pi over 2, and then eventually the vertical shifting, and finally the reflection using the negative sign before the function. But I have to first scale my horizontal line up to 2 pi over 3. And it's always a good idea to break it up into 4 intervals. In other words, I will start with pi over 6. All right, so let's mark pi over 6 to start with. And then 2 pi over 6, which is the same as pi over 3, correct? And then the next will be 3 pi over 6, which is the same as pi over 2. And then I'm going to mark 4 pi over 6, which is the same as 2 pi over 3. That gives us a full cycle of this particular graph. Let me move this interval a little bit to the right. So let's say that's 4 pi over 6. So now I have scaled the positive x-axis into 4 intervals, starting from 0 at the origin, and the next one is pi over 6, then 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, and then finally 2 pi over 3, which is 4 pi over 6, correct? And let's mark a 3 here along the vertical axis. There's a positive 3 and likewise a negative 3 on the negative y-axis. So the graph of 3 times cos of 3x would look like this. So this would be the graph of 3 times cos of 3x. This is going to be its shape. Now, we have to factor in the phase shift. So now I'm going to draw this graph in another color, introducing the phase shift of pi over 6 units to the right. All right, so let's do that. The entire graph is going to shift pi over 6 units to the right. So what began at 0, that means y equals 3 at 0, would move pi over 6 units to the right. So this point, which was at x equal to 0, it was 3, has moved pi over 6 units to the right. And what was at pi over 6, y was equal to 0, that moves pi over 6 units to its right. And this point here, which was at pi over 3 originally, so this point here moves pi over 6 units to its right. This point moves here, and then the one right here on top moves here. So let's connect the red dots. So now we obtained a graph which is for 3 times cos of 3x minus pi over 2. Let's write the equation for this graph. It was 3 times cos of 3x minus pi over 2. So now we have to introduce the vertical shifting of the graph. The vertical shifting, the graph moves up by 2 units. So what that means is, and I'm going to use a different color at this point, all these points are going to move 2 units up. In other words, that means you have to add 2 to 3 on the vertical axis and 2 as well to negative 3. So 3 plus 2 equals 5, which means the starting point of the graph would be 5. All right, I'll mark this point on the vertical axis as 5. So this is going to move up 2 units. All right. Likewise, if you add 2 to negative 3, you get negative 1. That means what was at negative 3 before is going to be now at negative 1. So now let's connect the points again. We have one point here, and this point is going to move up 2 units also somewhere here, and this point will be here. So let's connect the points. So now this green graph will be 3 times cos of 3x minus pi over 2 plus 2. So we are almost there. All right, this green graph is what the graph is. We are pretty close. Now we have to factor in this negative sign. So that means we have to factor in the negative sign now. That's the final step. What the negative sign will do is all the points above the x-axis will now go below the x-axis, and all the points that were below the x-axis will go above the x-axis. All right. So this green point at pi over 6 is going to move down, and all the points that were below the x-axis will move up. Now, instead of cluttering the graph, let's look at the choices we have. The graph, which is B, is definitely not the right graph because there's a vertical shifting down. Our graph needs to move up. All right, so this is not the right choice. C is also not the right choice because, again, here too, the entire graph has come down. There's a vertical shifting of down when we need a vertical shift going up. So the choice would be between A and D. Now the graph, which is A, matches the green graph, correct? See, it starts like this. It matches with the green graph that we have here, going like this. It does not factor in the negative sign. If you look at D, D on the other hand is a reflection of the green graph, correct? You see over here, this point, this green point on the graph we drew now has come down below over here. You see all the points are flipped below and above the x-axis, as the case may be. So this is how the graph looks within a period of 2 pi over 3. So what was an upturned U has become a downturned U once you factor in the negative sign. Therefore, D is our choice. Since this was a more elaborate function, that's why it was better to first draw the graph gradually, introducing one variation at a time, at most 2, and then look at the different graphs and try to eliminate and pick the one that matches the graph we would expect. All right?